All right, let's talk about something we've all probably seen, these super dense technical engineering reports. Today, we're going to take this flood report and just crack it wide open. The goal is to find the simple, powerful answers that are hiding inside all of that jargon. Ready? Let's dive in.
So, picture this. This thing, full of maps and tables and technical gobbledygook, it just lands on your desk. I mean, where do you even begin, right? How do you cut through all that noise to figure out what's really going on? Well, it turns out the secret is to start by asking the right questions.
And the first, and honestly, the most critical question is this. What's the real story this report is telling? Is it talking about that crazy, complex maze of pipes buried under our feet? Or is it all about what's happening to the water we can actually see, the stuff flowing right on the surface?
And boom, right away we get our first huge clue. The report is all about what happens when water flows over land, across the surface. This tells us pretty much everything we need to know. This isn't some deep dive into whether the underground pipes are big enough. Nope, it's about what happens right there on the street when a big storm rolls through.
You see, that one little distinction, it changes the whole game. It means the entire story we're about to uncover is happening right on the surface, on the roads, the sidewalks. The underground pipes, they're just a supporting actor in this play. And getting your head around that one simple fact, well, that's the key that unlocks this entire thing.
Okay, so we know our focus is on the surface. Now we've got to understand the rules of the game. And trust me, the best way to wrap our heads around this is with a really simple analogy.
I want you to think of a city's whole stormwater setup like your bathtub at home. Seriously. You've got that small drain at the bottom, right? That's the underground pipe network, what engineers call the minor system. It's built for your everyday shower. But what happens when a massive storm hits? The drain just can't keep up, and the water starts to fill the tub? Well, that tub, that's the streets, the overland flow paths. That's the major system, and its whole job is to contain all that extra water and guide it somewhere safe.
And listen, this isn't just me making up a cute analogy. This is exactly how engineers officially design these systems. The rulebook says, the minor system, our drain. It just needs to handle a pretty common storm, maybe a 1-in-5-year kind of event. But the major system, the bathtub, whoa, that has to be ready for a massive once-in-a-century flood. And what's key for us, our report is focused entirely on what happens in the bathtub.
All right, we've got the rules of the game down, so now it's time to dig into the evidence, the flood maps from the report. Let's start with a standard 1-in-5-year storm. Exactly the kind of rain those underground pipes are supposed to handle all by themselves.
So here's the thing. If the pipes are doing their job during this totally normal storm, there shouldn't be much water on the surface at all, right? I mean, that makes sense. Well, the flood maps in the report have the answer. So the big question is, how deep does the water actually get?
Okay, so according to the maps, on average, the water is only about maybe 3 to 8 centimeters deep. We're talking ankle deep, basically. Not too bad. But then you see this.
The maximum depth is over 1/2 meter. Hold on a second. How can the average be just ankle deep, but the deepest spot is way up over your knees? What are we looking at here? Is it a thin sheet of water everywhere? Or is there a small lake in the middle of the street? This is where we really have to zoom in.
And this little quote right from the report clears it all up. The deep water, it's not some continuous river. It's found in isolated spots. So what does that mean in plain English? We're not talking about a river running down the street. We're talking about a few really deep puddles that are forming in the lowest spots. See? The problem isn't a massive flood. It's very localized ponding.
Okay, so knowing the depth is one thing. That's like a snapshot in time. But we all know water moves. It's dynamic. To really get a handle on the situation, we need to know how much water is actually moving. It's time to talk about flow. So, that's the next logical question, isn't it? If we're going to even think about fixing this, we have to know what we're dealing with. So, how much water are we actually talking about? What's the total volume of all these puddles, and how fast is that water trying to move? So let's start with the total volume. You run the numbers, and it comes out to about 47 cubic meters of water, just sitting on that street. Now, to put that in perspective, that's nearly 50,000 liters. That is a huge amount of water with absolutely nowhere to go.
Now, how do we figure out how fast that water is moving? Engineers call it discharge. And it sounds complicated, but the formula is actually super simple. Q equals A times V. All you do is find the area of a slice of the water
estimate its velocity, how fast it's going, and multiply those two together. That's it. It's a really neat way to turn a static puddle into a moving river, at least on paper.
And check this out, because this is where it gets really interesting. Look at what a massive difference the slope of the street makes. On a pretty flat, 0.5% slope, the water just kind of creeps along. But if you double that slope to just 1%, the flow rate more than doubles. And at 2%, the street basically becomes a fast-moving channel. So the same amount of rain can be a tiny problem or a huge one, and it all comes down to the slope.
Okay, so let's recap. We know the problem isn't a giant flood, it's localized ponding. We figured out the volume of water and how it moves. So now we can finally ask the million-dollar question. Is the proposed fix actually going to work? Let's put it to the test.
So here's the proposal, a new 375mm pipe running the whole length of the street. The question is dead simple. If that pipe was totally empty and we could magically suck all that surface water into it, could it even hold it all?
All right, we know our number. To get rid of all that ponding on the surface, we need storage for roughly 50 cubic meters of water. That's the target we have to hit.
And the proposed solution? Well, we can calculate the volume of that new pipe, and its total storage capacity is only about 26 cubic meters.
And there you have it, the final verdict, laid out as plain as day. The problem is 50 cubic meters. The solution provides 26. The new pipe, it can only hold about half of the problem water, not even close.
So what's the big takeaway from all this? We've learned that a flood report might only be telling you the surface story, half the picture. And we've seen that a proposed solution might be less than half of what's actually needed to fix it. It just shows the incredible power of not just reading a report, but actually decoding it. When you ask these simple questions, you can figure out what's really being measured and whether the fix actually fits the problem. So maybe the biggest question is, what should we be asking before we build?